Good morning, all of you. Now, today we are going to study about this law of conservation of matter. Okay. Now, to conserve, what do you mean? The conserve to preserve. Okay. So, we are going to study what is the law of conservation of matter. Matter already we have studied about matter. Matter exists in three states: solid, liquid, and gases. Okay. Now, in the above activities, the mass we have seen in the above activities in the previous period, the mass of the original matter and the mass of the matter newly formed as a result of the chemical change are equal. So in the above experiment we have seen this, that the mass of the original matter and the mass after the reaction they are same or equal. So in 1985, the French scientist Antoine Lavoisier inferred, or he just came to know that, proved that from his research that there is no rise or drop in the weight of the matter during a chemical reaction. So what he proved? That there is no rise or increase or decrease in the weight of the matter during a chemical reaction. In a chemical reaction, the total weight of the reactant is same as the total weight of the product. So here in this case you see here, these two compounds are called as reactant, as already we have studied this: calcium chloride plus sodium sulfate, and whatever we have got, these are the products: calcium sulfate and sodium chloride. So according to Lavoisier, in a chemical reaction the total weight of the reactant is same as the total weight of the product from formed due to the chemical reaction, and this is called the law of conservation of matter. So what is the law of conservation of matter? Is that in a chemical reaction the total weight of the reactants is same as the total weight of the product, okay, formed due to the chemical reactions. Now next is the law of constant proportion. Now in 1794, after Lavoisier, the French scientist J.L. Proust stated the law of constant proportion. What is that? The proportion by weight of the constituent element. Constituent means whatever the elements are present in the compound, in the various sample of a compound is fixed. So what they are telling, that the proportion by weight of the constituent element in the various samples of a compound is fixed. For example, the proportion by weight of hydrogen and oxygen in water is 1:8. We know that what is the formula of water? So H2O. Okay, so 2 atom of hydrogen and 1 atom of oxygen. So in this, the proportion of hydrogen is 1 and the proportion of water is, the proportion of oxygen is 8. So this means that 9 gram water is formed by chemical combination of 1 gram of hydrogen and 8 gram of oxygen. So this is the according to the formula, that 1:8 is nothing but 1 gram of hydrogen and 8 gram of oxygen. Similarly, the proportion by weight of carbon and oxygen in carbon dioxide is 3:8. We know that in CO2, what is the formula for carbon dioxide? CO2, one element of carbon or one atom of carbon and 2 atom of oxygen. For example, in 44 gram of carbon dioxide, there is 12 gram of carbon and 32 gram of oxygen. Okay, so the proportion by weight of carbon and oxygen is 3:8. Okay, so as we know that 3 is the proportion of carbon and 8 is the proportion of oxygen, and that is the 3:8. And introduction to scientist Antoine Lavoisier. The introduction, we will see now what is about this Antoine Lavoisier, French scientist or father of modern chemistry. It is he is also called the father of modern chemistry. Substantial contribution in the field of chemistry, biology, and economics. So not only he studied in the chemistry and biology, but also in economics also. So nomenclature. What is nomenclature? Choosing the name. Okay, choosing the name of oxygen and hydrogen. Points are given to you. We'll see. Showed that matter combines with oxygen during combustion. Okay, so whatever burning, okay, when combustion or burning of something is there, the matter what we are burning is always combining with the oxygen in the air. Was the first to use accurate weighing techniques to weigh the reactants and products in a chemical reaction. So he was the first person to weight accurately. He made some arrangement, okay, so to weight the reactants and product in a chemical reaction. Discovered that water is made up of hydrogen and oxygen. So he is the person who has discovered that water is having the hydrogen and oxygen. Assigned systematic names to the compounds. For example, sulfuric acid, that is H2SO4, then sulfate, that is SO4, then sulfite, that is SO3. Okay, so see the difference between this: sulfuric acid H2SO4, then sulfate SO4, and sulfite is SO3. Then he is the author of the first book on modern chemistry. He was the author of the first book on modern chemistry. Then studied the elements such as oxygen, hydrogen, nitrogen, phosphorus, mercury, zinc, and sulfur. So he studied the different elements, all the given elements. Then first writer of the law of conservation of mass in a chemical reaction. So he was the first writer of the law of conservation of mass in a chemical reaction. So we'll stop here. Thank you.